To break the 4-hour barrier, the engineers have to build a train capable of carrying passengers at 380 kilometers per hour. A new world record for travel on rails. To avoid disaster, every part of the new railway, from the train to the track, bridges, signaling and stations, will have to be redesigned from scratch. For the designers and engineers of the new line, it's a true journey into the unknown. One of the parts that's most affected by high speed is the wheel unit, or bogie. Zhang Hong is in charge of creating the perfect bogie for the new train, a painstaking process of endless tweaks and tests. At high speed, if the bogie isn't perfectly balanced, the entire train can rock violently from side to side, or hunt. Hunting happens because the surface of each wheel isn't flat. It slopes, and the train can swing back and forth between these slopes like a pendulum. But Zhang Hong can't flatten the slopes because they allow trains to turn through bends. It works like this. The weight of a train is thrown to one side as it enters a bend, pushing the outside wheel onto the top of its slope and the inside wheel to the bottom of its slope. With the wheels running on different diameters, the train is guided into a curved path. Unfortunately, on a straight, the tiniest imbalance can cause these wheel slopes to hunt. And the faster you go, the worse it gets. Zhang Hong's latest prototype has passed every balance test the factory has to offer. But this place is a different proposition. Here there's a test rig that will make or break the new bogie. The Director of Research and Testing is Liu Hongyo.
In today's test, we will increase the speed up to a maximum of 420 kilometers per hour. If there's no big vibrations within that speed range, it means that the test is successful.
Liu starts the test slowly. The carriage needs to stay rock steady on the rig to pass the test. The slightest sign of movement and they'll have to abort, and Zhang will have to go back to the drawing board. It's a nervous time, but it's looking good. The test rig is now up to top speed, and the carriage remains as steady as when it was sitting still. The test is over, and it's a great success. The Beijing to Shanghai line is designed to carry the fastest trains in the world. But before they can take to the tracks, the trains must pass one crucial test for a mysterious phenomenon that can mean catastrophic failure for any construction. The phenomenon is called resonance, and it's a very violent form of vibration, seen here in exaggerated form. It's something that Vice Chief Engineer Ding San is working hard to avoid.
Resonance is a crucial design concern for the high-speed train, and is something that we spend a lot of time studying.
Resonance is the tendency of objects to vibrate most violently at certain frequencies. For example, this tuning fork always resonates at 440 Hz. The danger of resonance This is the way things behave when you expose them to their resonant frequency. In 1940, the newly opened Tacoma Narrows Bridge in the United States suffered catastrophic damage. The vibration of the passing wind was a perfect match for the resonance of the bridge. The energy of the wind fed directly into the bridge's vibration, making it resonate so strongly that it fell apart. To avoid disaster, Ding designs every part of the train to resonate at different frequencies by carefully selecting materials and the way they're joined together. This is especially important for the two largest components, the body and the wheel bogie. Today he's testing the body. Vibrating hammers are placed at each corner of the train head, and a technician slowly turns a dial. The test is over, and it's a great success. After 8 years of research, Zhang Hong can finally say that his bogie design is ready for the new track.
老白的电话你知道吗？还是稍等一下。哎，你说。